All right, you guys, this lesson is all about phase changes and what that has to do with heat energy. We have 1 page of notes that's going in your notebook for this, and then there's 2 practice sheets for you to practice this stuff when you're finished. So, you guys should have this chart in your notes. At the top you can see on the left we're going to represent this side of the page with low temperatures, and as you move to the right it's going to get warmer and warmer until you have high temperatures over here on the right. So when we're talking about matter, what type of matter exists at low temperatures? What state of matter, I should say, exists at low temperatures? Hopefully you said solids. As we take a solid and we start to heat it up a little bit, it's going to gain more heat energy. The particles are going to start moving a little faster until it turns into a liquid. And again, if we keep heating up that liquid, eventually it'll get enough energy to change state to be a gas. Now this spot, there's a specific temperature along this whole continuum where each individual different kind of matter will turn from a solid to a liquid. And that temperature is called the freezing point or the melting point. Depending on if you are going from a solid to a liquid, then that's the melting point. If you're going from a liquid to a solid, it's the freezing point. Same idea here between a liquid and a gas. In order to go from a liquid to a gas, you have to reach a specific temperature called the boiling point. Also, if you want to go from a gas back to a liquid, you would have something called a condensing point. Make sure that you fill in this whole chart. And then we have these pictures here. So again, we have our solid. We're going to use water as our example. So solid water is an ice cube. We have liquid. Liquid water is liquid water. And then we have a gas. And for our gas state of water is steam. Now, switching from one state to another is going to require a change in energy. Either you're going to increase the amount of energy the particles have, meaning you're going to heat them up, or you're going to decrease the amount of energy that the particles have. You're going to cool them down. So in order to go from a solid to a liquid, are we going to add heat energy or are we going to take it away? Hopefully you said we're going to add. So the arrow that I'm going to draw between the solid and the liquid is going to be red. You should do that red in your notebook as well. And that indicates that it's heating up. We have to heat up ice to get it to change into a liquid. And if it's heating up, that means that it's gaining heat energy. Now, when we change from a solid to a liquid, we call that melting. So we take ice, we melt it, we turn it into a liquid. Okay? We can do the same thing here then with a liquid to a gas. Now, in order to change a liquid to a gas, do we need to gain heat energy, heat it up, or lose heat energy, meaning cool it down? Again, you're going to have to heat it up. So let's draw that arrow in red. And when we change from a liquid to a gas, we call that vaporizing. We can go the other way as well. So you have, now let's say we have a gas, and we want to change it back into a liquid. In order to do that, are we going to gain heat energy, heat it up, or lose heat energy, meaning cool it down? This time, we're going to cool it down. So in order to go from a gas to a liquid, I drew that arrow in blue, meaning we have to cool these particles down to get to this step. Okay, we're going to have to take away some of that heat energy. You see this happening like in the bathroom. You take a hot shower, it gets steamy, and those hot gas particles hit the cold mirror. That cold mirror will cool them down and it will condense back into water droplets on your mirror, which makes it hard to see when you get out of the shower. Alright, the last one here, changing from a liquid to a solid, again we're going to lose heat energy, or we're going to cool down. Oops, sorry, that's called condensing. So here, liquid to a solid, we're cooling down. And to change from a liquid to a solid, we call that solidifying or freezing. Alright, make sure you get this all down. Make sure you have the correct color coding in there. I'm going to show you a chart that's not in your notes, but that's something you're going to need to understand. Okay? This is a phase change chart. So on this chart, on the bottom is heat. So over here on the left, it's cooler. over here on the left, or I'm sorry, is up here on the left is your temperature. So hot is at the top and cool is at the bottom. Okay. We're going to start off over here on the right, and you can see these are what the particles look like. This is when our substance is in solid form. So we're going to start increasing the temperature of those particles, and you can see that by the line going up. And as it's in a solid form, they're nice and ordered, and they're not moving a lot. Okay, it's going to hit this temperature here, and in this case it's at about 0 degrees Celsius. And you can see that our temperature levels off. Okay, and while that temperature levels off, you look up here and you go, oh, well, it looks like this substance is starting to change from a solid to a liquid. Parts of it are starting to be liquid, parts of it are still a solid. Changing from a solid to a liquid is called melting. So right now, where this flat line is occurring, we know that that water is melting. Now the reason why the temperature levels off in this place is because before all this energy was going towards heating up the particles. Once you hit that specific temperature that we talked about earlier, where a phase change is going to occur, all of the energy that's being added is going towards changing. So instead of heating up, all that energy is changing it from a solid to a liquid. Once all of these particles have changed to a liquid, you'll see now there's not a phase change occurring anymore. That liquid's going to keep heating up, keep heating up, keep heating up until you get it hot enough, in this case 100 degrees Celsius. And at that point, some of these water particles are starting to change into a gas. We have part gas, part liquid. Again, you see that flat line, which tells you there's a phase change happening. All that energy is going towards a phase change instead of heating up the substance. And it's going to remain flat until all of these liquid particles have changed to gas particles. And once they've all changed to gas, again, it'll heat up from there. Okay, so you can see as temperature increases, the energy of the particles do compared to the solid. And the other really important thing is just that when you have a phase change occurring here or here, you're going to see a flat line in the temperature while that's happening, and that'll be very important for your lab tomorrow. Okay, at this point, you're going to want to take these notes and see if you can apply them on your phase change concept map on page 94 in your notebook, and also your heat transfer work on page 95 in your notebook. And of course, if you have any questions, let me know.